In this video, we're going to solve 4 problems related to statically determinate trusses. For our first problem, we have to determine the forces in each member of the truss and state whether they are in tension or compression. Since we have to find forces in each member, we can use method of joints. Let's start with drawing the free body diagram for joint C. At joint C, we have 3 force vectors. One is external load, 40 kN, and 2 are from members CA and CB. Let's sum the forces in X direction. We have 40 kilonewtons going in the positive direction, and then we have positive. And to solve for it, we need to find the length of member CB. That would be 3 squared plus 4 squared square root. Solving this, we get 5 meters as our solution for the member CB. Therefore, X is going to be 4 over 5 times the 4 CB, all equals to 0. Solving for 4 CB, we get our solution as 50 kilonewtons negative. This means we assumed our vector to be in the wrong direction. Therefore, if we switch our vector, we can change our solution to positive. And since this member is pushing towards the joint or the pin, this member is in compression. Now let's sum the forces in y direction in order to find our solution for 4CA. We have our 4CA going in the negative direction. And then we have our positive 3 over 5 and newly found force 50 kilonewtons, all equals to 0. Solving for 4CA, we get our solution as 30 kilonewtons. This comes up to be a tension force because the member is pulling away from the pin, or the force is. Now we can solve for our joint B. At joint B, let's draw the free body diagram for B. So we're going to have a reaction from the roller. We're going to name it N sub B. We have reaction for force AB. Then we have another reaction for force CB. We already know our CB value, and it's 50 kilonewtons. And it's in compression. Let's sum the forces in X direction in order to find the value for our force or member AB. And have 4 over 5 times 50, and then negative force AB equals to 0. Solving for force AB, we get our solution as 40 kilonewtons, and it's going to be in tension. Now let's sum the forces in Y direction in order to find our reaction for the roller. So it's going to be 3 over 5 negative times 50 plus our reaction at B equals to 0. Solving for reaction at B, we get our solution as 30 kilonewtons. For our problem number 2, we have to determine the forces in each member of the truss and state whether they are in tension or compression. Let's start with the joint B. So we have to draw the free body diagram. And again, because we are looking for reaction forces in each member, we can use the method of joints. So at joint B, we have external load of 6 kilonewton. We have reaction force from member AB. And we have reaction force from member CB. So let's find the value first of all. Our length for the member CB is going to be 2 squared plus 2 squared. It's going to be square root of 8, which comes up to be 2 point. Now let's sum the forces in Y direction. We have negative 6 kilonewtons. We have positive 2 over 2.282 times the force CB, all equals to 0. Solving for force CB, we get our solution as 8.4 kilonewton, and this member is in tension. Now let's sum the forces in X direction. We have our negative force AB, and then negative 2 over 2.828 times our newly discovered force, which is 4.485 kilonewton, all equals to 0. Solving for force AB, we get our solution as negative 6 kilonewton. Because it's negative, we know that we assumed our force attraction to be in the wrong direction. We can switch the direction of the vector, and then we can also change our value to positive, just for the simplicity's sake. And this also makes our member into the compression force. Now let's sum the force, get the forces in joint C. At joint C we have force from member CB, which is 8.8, which is 8.485 kilonewton. Then we have reaction, horizontal reaction at member DC, and we have a vertical reaction at member CA. Let's sum the forces in y direction. In order to get the value for member CA, we're going to have 2 over 2.288 negative, and it's times by our force at member CB is 8.485 kilonewton. Take away our force at member CA, all equals to 0. Solving for member CA, we get our solution as negative 6 kilonewton. That means we assumed our vector to be in the wrong direction. It's going upwards, and therefore this is in compression. Now let's sum the forces in x direction. We have again 2 over 2.828 times 8.485 kilonewton. Take away force DC at member DC. Solving for force DC, we get our solution as 6 kilonewton. For this problem, we again have to find forces in each member and determine whether they are compression or tension. Let's start with joint C by drawing the three-body diagram. At C, we have external 10 kilonewton, and then we have force vector from member CB, another force member from member DC. Okay, let's start by summing the forces in x direction. You're going to have positive 10 kilonewton force from the external load, and then negative. Before we do that, we have to determine the length of member AC, which is going to be square root of 3 squared plus 3 squared, which is going to be 3 root 2, which is same as 4.24. Now, let's get back to our equation. So it's going to be 3 over 3 root 2 times our force DC, all equals to 0. Solving for force DC, we get our solution as 14.14 kilonewton, and this member is in tension. Now let's sum the forces in y direction. It's going to be 3 over 3 root 2 times our newly discovered force, which is 14.14 kilonewton. Take away force CB equals to 0. Solving for force CB, we get our solution as negative 10 kilonewton. That means we assumed our vector to be in the wrong direction. By switching the direction, we can change our sign for the value, and it also confirms that this member is in compression. Now let's sum the forces in joint D by drawing its free body diagram. At joint D, we have already found our force DC. We don't know our force, and we don't know our force for member DB. By inspection, we know that force at member DB is going to be a 0 because it's a 0 force member. If you don't know, you can go back to the earlier video where I've explained what it means to have a 0 force member. Now, we just have to tilt our axis in order to avoid simultaneous solutions of equations. So that's what means if we sum the forces in x direction, we should get our solution for force dA, which is going to be simply 14 kilonewtons in tension, because there isn't any other force acting on it other than the force from member DC. Now let's get to the joint B by drawing its free body diagram. Looking at the vectors, we know that force dA is going to be 0 because it's a 0 force member. DB. And then we have already found the force for member CB or BC, which is 10 kilonewtons, and it's in compression. Then we just have to find our force for direction of the roller at P. And before we go to the roller, we also know that our force BA is going to be 0 by inspection because there isn't any other horizontal force acting on this joint. And without even using the equilibrium equation, we can state that force BC is going to be, external reaction of the roller is going to be 10 kilonewtons because force BC is the only reaction that's occurring at this joint. For our last problem for this video, let's start by the joint D. At D we have 2k external loading, then we have vector from force dA, and then another vector from member DC. Now, by inspection, we know that force dA is going to be 0 kilonewton because there isn't any vertical action occurring at this joint. And also by inspection, we know that because there isn't any other horizontal reaction other than the external load, our force DC is going to be 2k as well, and it's going to be in tension because it's pulling away from the joints. Now let's get to joint C. By drawing its free body diagram, we have already determined the force for member DC, which is 2k. We have a diagonal vector force from members AC, and then we have another one from member CB. Before we proceed now, we have to determine the length of member AC, which is simply going to be square root of 6 squared plus 8 squared. Solving this, we get 10 as our solution. Now let's sum the forces in x direction. We have negative 2k, and we have negative 6 over 10 times force AC equals to 0. Solving for force AC, we get our solution as negative 3.33k, and this means we have assumed our vector to be in the wrong direction, and this member is going to be in compression. Now let's sum the forces in y direction in order to find the force value for member CB. So it's going to be negative for CB, positive 8 over 10 times our force AC, which is 3.33, all equals to 0. Solving for force CB, we get our solution as 2.67 kilonewton, and this member is going to be in tension. Now let's quickly get to member or joint A in order to find our solution for the last member AB. So at A, we have a zero force member dA. We don't know the direction from the roller yet. We have just found the value of our vector for AC, which is in compression, and it's 3.3k, and we don't know the value for our force value for our member AB. Let's sum the forces in x direction in order to find the value for our force AB. It's going to be positive force AB, take away 6 over 10 times 3.3, which is the value of our member AC, all equals to 0. Solving for force AC, we'll get our solution as, for force AB, we'll get our solution as 2k in tension. Now let's sum the forces in y direction. We have our external direction from the roller, and we have negative 8 over 10 times 333 equals to 0. Solving for the external direction at the roller, we get our solution as 2.67k.